Okay, so we've worked our way up to the 1904 Nobel Prize in Physics, which was won by this guy right here. This was actually a really interesting one, and the winner was actually probably more interesting than the prize in ways. The winner was a guy named John William Strutt. He was the third Baron Rayleigh, so he was a guy who was born into a title somewhere along the line, and became one of the probably most influential scientists of his time, but also gave us a lot of things that we actually care about. So he did a lot of things outside just the prize winning stuff, but they chose to award him for his investigations of the densities of the most important gases and for his discovery of argon in connection with these studies. There's a big fancy way of saying the guy was a very careful spectroscopist, which is a big fancy way of saying measurement of things, and he was able to isolate and identify the weights of different gases. One of the things that he did was he discovered argon as his own unique element, and the entry on the periodic table came from that. This is an argon discharge lamp. So you put argon in the presence of no oxygen, pass enough voltage through it, and you get a nice purple glow. Interesting stuff. But what does this work really do for us? Well, Rayleigh scattering is really what led to all those measurements. So he was very careful at studying how things scattered and how waves pass through gases. And one of the things that Rayleigh scattering does is it explains why the sky is blue, but the sun isn't. So, the sun is this yellow star, and all of a sudden the sky is blue. Was how that happened. Well, light comes in from the sun, gets scattered around in the atmosphere, and we perceive the blue part of it as it comes through. That's why sunset's a different color, sunrise could be a different color. You can get different shades depending on the time of day. That's why the sky is the color it is because of Rayleigh scattering. He basically did a lot of studies on surface waves in solid, which led to seismic detection, material characterization. When are you going to have an earthquake? Those kinds of things, slightly important. Heavy contributions into fluid dynamics, which allows airfoils on aircraft to be designed, petroleum pipelines to be developed. Predictions in weather patterns come out of fluid dynamics. He was sort of an early guy in that space. He had a theory on aerodynamic lift, which might lead to airplanes flying around. The Rayleigh-Jeans law, which plays an important role in quantum mechanics. Black body radiation used in labs all over the world kind of came out of that. And he wrote a book on the theory of sound that is still used today, and we're still catching up to it. So think about for a second the sound quality coming out of a smartphone versus just the speakerphone just 10, 15 years ago, worlds apart from one another. Think about how your noise canceling headphones sound today versus 10, 15, 20 years ago, worlds apart from one another. That acoustic work is still being kind of studied and still being understood by engineers, even today, more than 100 years later. The prize, as I said, was used for his measurement of different gases. What he was doing was measuring the weights of those gases, and the weights of those gases led you to where they fit on the periodic table. And they kind of discovered that argon was its own thing, which is important. And there's a lot of uses for argon, but the Rayleigh scattering and the way he was measuring just the way light kind of moves around through space led to things like fiber. It's still used in fiber optic engineering. I mean, he didn't directly get to fiber optics, but because it was early 1900s, but he a lot of the mathematical constructs that he put together and a lot of the understanding leads us to mathematics that's done in showing where to put fiber optic repeaters and where to put boost signals and how to get different things through fiber optic in a more efficient fashion. It's all his math, still being used 120 years later. Now, argon is one of the reasons I think they awarded argon was they saw a bunch of practical uses of it. Argon is an incredibly important gas in a lot of processes, and some of those are in healthcare. It's used in the treatment of retinal detachment, retinal phototherapy for diabetics, surgical procedures. So argon laser therapy, argon lasers are used because it allows a non-oxidizing gas to get in there, and you don't want oxidation or you get fire. That's a bad thing. So it's a very important one. Used in the food or drink industry. If you want to really truly preserve wine, let's say you've opened a very expensive bottle of wine, and you want to preserve it, instead of leaving it in an oxygen environment, you pump it full of argon and reseal it. or use argon to prevent it from oxidizing in any fashion. And, bingo, bango, there you go. You've got wine preserved for a much longer period of time. Manufacturing, it is used in welding all the time, again, because it takes sort of oxygen out of that loop and doesn't allow oxidation of the surface. So, his discovery of argon led to a whole bunch of things that are still going on today. His discovery of sound or his discovery of how sound works. He didn't discover sound, obviously. Um, Leads us to engineering work that's still taking place today. His Rayleigh scattering still being used today. But yeah, he had one other contribution I thought was interesting, was because of his baron rank. He could interact with people at the House of Lords, and he would have had a tendency throughout his career to go do that. And he would go sit in the house and he wouldn't say much. And the only time he would ever speak up was humorously, at least humorous to me, was when politics would get involved in science. And he would try to shut that down and say, no, you got to focus on the science, leave the politics out of it. This is, this is this and that's that. So the only time he would ever speak up was to eject politics out of the room when discussing science, which I thought was a very interesting thing, and something we should probably have more scientists do today, and certainly something I didn't actually know that before researching this video. I was researching a little bit about his life, trying to find nice little factoids. But something I would urge every scientist, and including myself, to do is to start to call crap when you see politics entering the scientific world. And something that I think, from now on, I might be more prone to get involved with personally. So, thank you, Baron Rayleigh, and whose real name was John William Strutt, for showing us that can be done. And politics actually has absolutely no place in science. So, everybody have a great day. If there'll be more Nobel Prize videos coming up, click like, subscribe, or follow wherever you see me. All these videos are put together in a playlist. So if you're looking for any of the older ones, feel free to go through that playlist. The more recent ones will be coming up as soon as I get time to put them all together. So everybody have a great day.